Hello friends, so in today's question, if the acceleration is towards the right, the frictional force exerted by the block will be, the coefficient of friction between the wedge and the block is given as root 3 divided by 2. So here the acceleration is towards the right, okay, in this direction. So this is a slight correction, so this will be root 3 by g. So we have a wedge and our weight, we have a small block whose mass is m, and we have to find out the force exerted by the block. So let's draw the free body diagram. Let us call this angle theta, and we have a block m. So we are going to have mg in the downward direction, which can be divided into two components. This angle will be theta, so this will be mg cos of theta, and this will be mg sin of theta. And because the wedge is moving towards the right side, so there will be a pseudo force which will be acting on the m toward the left side. So this is our MA, and this is our pseudo force. And this pseudo force can be divided into two components. So this angle will be theta. So we are going to have this as MA cos of theta, and this will be our MA sin of theta, and there will be a normal. Okay. Now we say that because of the pseudo force MA cos of theta, the block is trying to move in the upward along the inclined plane. So we are going to have a frictional force Fr in the downward direction. In this case, we say block M is trying to move up the inclined plane due to MA cos theta. Cos theta, therefore frictional force Fr is down the inclined plane. Now let us write the equation. First of all, with respect to normal, we can say that our n will be equal to MA sin theta plus mg cos theta. MA sin theta plus mg cos theta. And let us find out the value of MA sin theta and mg cos theta. And theta is our 30 degree. You can say that, and it is moving in this direction with the acceleration A, which is given as root 3 by g. So we can write our MA sin theta will be equal to M. A is given as root 3g, and we have sine of 30. So ma sine theta will be coming equal to as root 3 divided by 2 multiplied by mg, and next is mg cos theta. Okay, write it here, so I can say my mg cos theta will be equal to mg and root 3 by 2. So we can say that abnormal n will be equal to root 3 by 2 mg plus root 3 by 2 mg. This will be coming equal to as normal is equal to root 3 mg. So from here we can find out the limiting value or maximum value of the frictional force. Thus the limiting value, limiting or maximum frictional force, which we can say is Fr max, will be equal to mu into normal n, and mu is given as root 3 by 2. Normal we get as root 3 multiplied by mg. So our Fr max is equal to 3 by 2 mg. Let us call this equation number 1. Okay. So we get root Fr max, that is limiting value or maximum value of frictional force, root 3 by 2 into mg. Now next let us find the actual value of the frictional force, which will be the between the block and the wedge. Actual frictional force between the block M and the wedge. So we can write the equation that Fr mg sine theta. Okay, so this will be Fr plus mg sine theta is equal to ma cos theta. Oh, okay. So you can say that Fr plus mg sine theta is equal to ma cos theta. Once again let's find the values. Mg sine theta will be equal to, we have mg sine of 30, and that will be equal to mg divided by 2, and next is ma cos theta. So we have m and a is given as root 3g and cos of 30. So we are going to get this as ma cos of theta, cos of 30 rather, will be equal to 3 by 2 mg. So from here we put the values and we get Fr is equal to ma cos theta, that is 3 by 2 mg minus mg by 2. So we can say that the value of the friction between will be equal to mg. Okay. So the value of Fr max is 3 by 2 mg, whereas the actual value of the friction, that is because of the forces which are acting on the block M, is mg. So if you compare, let this be equation number 2. So from equation 1 and 2, from equation 1 and 2, the required value of the friction is less than the maximum value of the friction. Maximum value of the friction. So you can say that Fr is less than Fr max. So from here we can draw the conclusion that no slipping takes place between block M and the wedge. So under this condition, the value of the friction which we are required to find out, you can say the frictional force. Thus we are required to find out the frictional force, exerted by the block. You can say that thus the frictional force exerted by the block M is equal to Fr, which is equal to mg. So this is our final answer. Thank you.